So last time I started working on this multi-gap buffer, um, and I ended up spending a ton of time debugging some completely unrelated crap. So now I'm gonna get this to work. And obviously it wasn't even compiling before. And after I did some thinking, I realized there's just a bunch of really stupid problems with this that I was ignoring or not thinking of before. But this mem move here is going to be a little bit wrong because it's moving gaps over other gaps, and those gaps contain pointers to memory, and I'm going to leak the memory of the gaps that I copy over. So what I really have to do is I need to keep those gaps around somehow, some other place, and just mark them as empty so that I can reuse them later, right? So have like at the end of the array of gaps, what I'll need is, I can sort of see it in my head now, but let me draw a picture so if you're seeing the picture you'll see it with me. I have a bunch of little chunks, right? Chunk, chunk. Wait, let me just draw it this way. Chunk, 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 chunk. So each of those gaps there is one of my chunks, and all of them may have pointers off to some memory or not. So say like the first 4 are actually used, and the 5th one I have just an empty null chunk there. But then some of these might not be used, so only these ones are actually filled with text. So I have actually the concept of where I'm actually using up for text, where I have allocated but unused chunks, and where I have like pointers to chunks that aren't actually pointing to anything yet. So I need to move to that system. There. Hello, insofar as multi-gap buffer. See, I have a chunk count, a chunk max, and then I need like a chunk used count, or I'm already using, I need more like chunk right? So that's where I keep chunks. Everything after this but before this is allocated but not used, basically. And when it becomes time to do that mem move at the bottom, before I replace everything that gets replaced there, I want to somehow move it. I want to save those and not those mem moves actually. This one. I'm moving gaps over other gaps, but the pointers need to be saved when that happens. So it's more like I have well, I can think about it this way. I have a series of symbols A, B, C, D, E, F, G. And I have some symbols here that I'd like to move to this position, right? So I'd like this E to be here, but when that's done, I'd like to take these and move them here so that I don't lose anything, right? So that the result becomes A, B, E, F, G with C and D still in existence, just planted over here on the end. Because then I can go and say, like, mark those as unused but keep the memory, etc. And then I have what I was imagining I had, where these are the ones that are in use still that have text I care about. So how do I do that? That's the next thing I need to do. And doing it in place seems somewhat impossible. Well, no, I could swap. Swap. Yeah, it seems pretty hard to figure out a reliable way to swap those in, right? Like, two unequally sized chunks. I could do a thing where, like, I take the D, copy it out, shift everything down one, and then paste the D, and then copy the C, and, like, insert it one at a time, like that. It'd be really nice if I just had some scratch space where I can say, hey, make sure you've got enough space, put down C and D in the spare space, then do this mem move, and then mem copy the CD right there, right? And I might have that scratch space here on the end. So what I could say is, in order to do this, the amount of space I'm going to get replaced has to exist off the end in the unused portion so that I have scratch space. If it doesn't, then I need to request a growth of that array first. So I'm going to try that. So we come here, we know that, right, so we need to check how much space we have for moving that spot that we're trying to, how much scratch space we have off the end, right? So if, like, buffer alloc, chunk allocked minus chunk max minus what's allocked, and I care if that is greater than or equal to the part that I'm about to write over. And the part that I'm about to write over is, well, looking at this again, if these are chunks, then this is where my edit begins, this is where my edit ends, and so I'm about to write over 2 in that case, right? I have gap start, gap end. So it's like if gap start or gap end minus gap start plus 1, right? So if I have that much right there, then I can go ahead and do what I need to do to move forward. And the stuff I have to do to move forward, in the other case, I'll have to enough space in gaps. Alright, and then I have to do is I mem copy everything to the alloc position from gaps plus 1 or gap plus 1 with the amount of it being this much, right? I believe I'm using and spelling that word correctly, but I'm going to check it real quick. Because me believing that means basically nothing. Oh, there's not even an R. It's not. I'm not even thinking even close. It's not surplant. It's supplant, past tense supplant. Okay, it's not surplant. It's just supplant. That is good. Maybe there's a word called surplant that I'm not. That's different. That I was picking up in my head there. Thinking of. Okay. Anyway, that so many gaps are being supplanted. So we move that to the end. And then basically what I have, which is kind of nice, is I now have, you know, some spare space here that I don't care anything about. So I wrote my C and D there, and what I was going to do next is take EFG and move it to this position. But now the next thing I would do is take CD and move it the exact same distance to here. So it's just going to be taking all of this and dropping it right there. So that just means I take, instead of chunk count minus gap end, I care more about, better multiply that by the size of a gap though. Okay. Anyway, I was saying, instead of this much, it's more about, how much is this amount? 'Cause it's the same size. That's alloct minus start, well, minus start minus 1. Okay. Interesting. Okay. And then I decrease the chunk count, but not the alloc count, right? The alloc count's going to stay right here when we're done. Whereas say the chunk count was also here, it's now going to drop down to here when it's done. So that's fine. Yes, that's okay. That's all seems good. So now there's the question of what do I do when I don't have enough memory to do that trick. And then the answer is I need to set my results to 1 because we're going to do a memory request. I set the request amount to equal size of one of these times the chunk max times 2 increase all of that by 1 for good measure, because you don't want to have a situation where you get stuck with a 0 that doesn't multiply up. And then round that up to 4 kilobytes. Then say you have a result of 1. Now the question is, if I do this, I don't really want to do all of that, so I think I need to go to MuGaB replace range end. I need to go to the end at that point because I don't want to do anything after that. Now what? We're requesting the memory. What I think I want to do is say, whenever you send out a request, there's a number of times when I might send a request out of the system. It needs to know what, the buffer needs to have a little bit of state for keeping track of it needs to have some state for keeping track of the allocation it's about to get back, right? If it's going to get some incoming memory, it needs to know what it's supposed to, like why it requested that memory in the first place. So something like maybe well, basically it could either be growing this or actually allocating for a gap. So grow gaps. So that'll be 1 when we're expecting to grow gaps and 0 otherwise. And then other than that, I think the rest of the code, I think that should be the only thing I need. So whenever I request the memory, grow gaps, we'll set to 1. I need to look at, for comparison, the normal gap buffer provide memory. Is this right after replace range? And init, this is edit provide memory. Why is this way up here though? Should be more like should be more like down here, right? Probably want to do the same thing in the other one. Edit, provide memory, throw you right there. Okay, so so what I wanted to do next was provide memory to the MuGaB. Alright, so now when the new memory comes in, we want to take a look and say what situation is the buffer in. Was it expecting I forget the name of the variable already. Grow gaps. No, I don't know anything about ActionScript or ActionScript 3 or any other version. Okay, so in this situation what I want to do is I want to say here's the new max. That's kind of a poorly named variable, but whatever, I'm going to stick with it. Or I'll just change it for this one because this one actually does need a different name. The other versions don't need the same name, but Dementalist, I don't know C# for one thing. I learned it a little bit at one point. The main reason I don't want to use C# is I don't believe, I mean this might not be true or anymore, but at one point it was heavily reliant on .NET and you couldn't make a portable application in C#, I don't think. That might be fixed now, I don't know. But I mostly want just to do it in low level so that I can compile to a binary and just put it on any operating system and do other fancy stuff like that. So when this comes in, it'll assert that the size has to be greater than or equal to chunk max times the size of gap. So we need something at least as big, if not hopefully bigger than the original. Yeah, Direct Ryan makes a good point. I think a lot of people think that the main trade-off between high-level and low-level languages is performance, and they think if you pick high-level you get a bunch of power in exchange for not as good performance, but you get more expressive power, and if you take low-level you lose some expressive power and you gain performance. But I don't think that's true. I think that there's a second trade-off at least. You maybe give up some expressive power, as in there are certain things that are more verbose to express. It takes more work to express them, but a low-level one. A low level one, like a low level in which can express anything, right? So it's more powerful, and sometimes high-level languages just aren't flexible, right? They aren't able to express things the way you want them specifically. You have to use specific ways to express them, or the low-level language can give you more ways to express the same thing. So it's actually more powerful too. The only thing you actually are trading on when you pick low-level is effort you have to put in to make something happen. Sometimes you're trading on that, and sometimes you can still win on the low-level language for that. Okay, so now what I have to do is, the old data is going to be, in this case, the gaps. I'll copy into the new data from the gaps the chunk alloc count times the size of that. This is the gaps. Fixed with gap buffer, and the chunk max then becomes the size divided by the size of gaps. Okay, so that does a memory grow for the gaps array. Otherwise, when memory comes in, I'm not entirely sure what I want to do with it, so I'm going to ignore this case for now. Say I have to get back to this. I haven't gotten this far yet. But I suspect it'll be something about taking some memory and throwing it into the end of an array, the empty space, and then having the rest of the system figure out when it's there that it can use that and stick it in where it needs it. I don't want it to do tons of moving around, so I'll probably have it say if there's not enough alloc space, get another chunk and it'll grow the free alloc space, and then it'll swap that into the middle where it needs it. And the other thing I could do for optimization is talk about having gaps not be sub-allocated one at a time, but the downside to that is it complicates. Like, I have to figure out each gap, I have to label whether or not it is the head of a chunk of memory or not, and if it is, free it. If not, don't free it. And yeah, I'd rather just keep the simplicity of freeing all of them for now. So that's why I'm going to leave it that way. And then here we are. Okay, so if we need memory, we either take it off the end, or if there's not even enough memory on the end, we grow. And now the next time we come through, we should have enough memory. Oh, you know what I should do is add in how much memory I need supplanted gaps instead of just one. That way I'm guaranteed to only fail the first time. That's good. And I'll add that into the inside so it's getting multiplied. Okay, so we double, plus we make sure we have enough for the supplanted gaps. We round up to 4 kilobytes. And then that's how much we request. That way we're absolutely guaranteed by this part here that I'm getting the correct amount, and that I'm also amortizing it so that if this won't happen every single time this gets called, hopefully, and we copy to the end of the array. We then move everything back, and we update the chunk count. We figure out where at the end of this array we end, and we clear out the end position so it doesn't think it still contains that data. And then I set gap back 1 so that it's ready for the next thing it has to do, which is it has to figure out if the end goes beyond the first chunk to put the end inside the first chunk. And then if we calculate the shift amount of, what is this, the shift amount of the whole thing though? Oh no, this is after I update end. So this is the shift amount within the local chunk. Okay. Because now end has been fixed if it needs to be fixed. I figure out if that's gonna fit, and I do the gap buffer stuff if it's gonna fit, so that should all be working. But now here's more memory request stuff. So it's gotten to this point and it says, hey, when I do this insert, it's not gonna fit inside of a fixed width gap buffer. So how am I going to fit all this text? I'm gonna need more memory. And to get more memory, I have to figure out how many more chunks I need. So first thing I do is I say, here's how many more empty chunks you're going to need. We don't necessarily know result 1 yet, so I'm going to take that out. The next question is how many empty chunks do I need? How many do I have would be the next question. So it's like, the amount that I have is however many are allocked minus the actual chunk count. Right, so that's how many are actually free. And if that is greater than or equal to the required amount, required empty buffers, and Bob's your uncle, you do the hard thing here. Right, so instead of doing that end, I'm actually going to do the memory request end. No, I'll do this one first since I have it on my mind right now. Result equals 1. The request amount is 1 fixed width buffer size, right? So I ask for one chunk of size fixed for 1 fixed width buffer, and I say I'm going to need that new memory, and it goes out and gets the memory, and then it'll get passed in through here where it wants to get pushed onto the end, as I was saying before. So let's take care of that. Ooh, it's a little nasty. I'll have to think about something else too. Yeah. The other nasty thing is once I do this step, I don't really want to repeat that again. So I'll put a reminder up here, don't repeat all this shit every time, somehow. Okay, so if I'm getting a new chunk, the other thing I have to do is when this comes in, I want to do a couple of asserts. I want to assert that chunk max is going to be greater than or equal to chunk allocked plus 1. Or I can just assert that it's strictly greater than allocked will be better. And then at the end of the allocked chunks, I go grab one of these up here. And then okay, what are we doing? It's time to take the gap and give it, well, first I wanted to zero it out and give it some data. The other thing I need to do is assert that the size that we got was at least big enough Domentalist, what does Internet Explorer commenting style mean? I mean, I might be doing, I don't know. Alright, so next I need to, that's gonna, whenever that memory comes in, it'll grow the, allocked portion. I want to go look at my initialized stuff real quick. Okay, that's good. Yeah, okay, so I don't think anything, no one else really cares about allocked until we get back down to replace range. Okay, so now I want to deal with the fact that once I've gone down this path, I don't ever want to go down it again until the beginning of a new replace range, right? So that means when I'm doing a replace range, I need to know if I'm gonna do all this work. Haha, I see. These to-do comments are more like short-term, reminding me of my trains of thought, like I need to do this and that. I also have to-dos that are kind of more like permanent versions of this, but this is like me reminding myself of the next things I need to work on. Because I'm about to get rid of this one right now. The trick here is only to do this work if buffer edit stage equals 0. So let me go introduce that concept. It'll be initialized to 0, and then once you get through this part here, if buffer chunk max do that. The question is, if gap start is less than gap end, then see how much we're going to supplant. If we can fit it, do the work. If not, get out. But there's always the possibility that we don't have to supplant anything. Either way, I want to set edit stage here. Right, so it's more like set the edit stage to 1. so that this does not get repeated in repeated calls of the same edit, because I don't want all those mem moves happening multiple times, basically. And the only time this gets skipped is when we needed memory, so that it will actually repeat that stage in that case. Then it comes down here and it says, alright, this part here might not need to be skippable, but I definitely don't want to set it back to 0 unless I've totally completed the edit, right? So if I totally complete my work, I can set the edit stage back to 0. So if I go down into this region, right, before I can do any of this, I might have to grow the gaps for that too. So I need an if down here that says, look, if alloct is still less than max, do this work. Otherwise, what we actually need to do is another one of these up here first. So then, next time through, it'll come through and do similar work again. So the slight downside to this structure that I'm seeing so far is the amount of work it's got to do in order to keep everything allocated. I could do more work to say that I just throw everything into one buffer and grow it as needed, but that would come with the downside that you would still have to do all of the mem copies that you're always doing anyway. Like, anytime you do an insert or something, you won't get that much win. Like, you'd get on a semi-rare occasion, you'd get an expensive operation like usual, but it would be like as expensive or more expensive than inserting into a gap buffer when you have to do extra moves and allocates. So it seems like it could be much worse in the worst case, but it would be even more rare than a gap buffer. But then, so like that's the trade-off you make there, but the amount of complexity and like the streaming speed and stuff is slower. I don't know, I'll have to wait till I measure it, but I feel a little bit like unsatisfied with this just because of the amount of complexity that it adds, that it'll have to be a big win for me to say that I like it. So it'll come down to what happens when I measure it. Now, if we're in a situation where we have all of the alloc chunks that we need ready to go, then the time has come to finally fill them and put them in the right position. But this is where I have to do another one of these annoying swaps. Right, I have to do a swap like this again. The only difference is now it's more like I have some unused but allocated chunks over here that I know I have the right number of, and I want to swap all of them with all of these. But the good news is I don't really care about the order of these ones now, right? So I want all of these, I want all of these to end up right here, and then I want all of these to end up right here. But I need these to stay in order, but I don't care if these stay in order. I wonder if that makes it any better. It seems like it doesn't really help much because I still have to take everything that's about to get replaced and back it up somehow. So it's like I still gotta hope that I have, this scratch space over here, so that I can take these three things and back them up into this space, and then do this move, and then take these and move them here, right? The other thing I could do is just use the same formula that I have from before to make life even easier on me. Put these three things right here, E, F, G, and then move this chunk back to here all at once. That's probably what I'll do. that's probably what I'll do. Alright, so to do that stuff, what's it gonna take? I have to make sure I again have to do what I did up here, and make sure I have at least enough memory to do what I'm trying to do. So I need like the supplanted gaps variable again, and all this is kind of similar. None of this is the same. That'll be for later, but let me figure this out. So the amount of supplanted gaps is basically there's the start. Here's the chunk count. Here's the alloct counter. Here's 0. I need the amount of memory that's here basically. So everything in this range from count minus start minus 1, right? Um, So to compute the new supplanted gaps amount is basically start gap or gap start, I forget which. Gap start. Gap start, and I want to subtract out the chunk count, or subtract that out of the chunk count, and then it's 1 less than that, unless I've done some error in thinking. That's how much about to get supplanted, and if you can't fit that, you do another memory request. Very good. This down here doesn't care about supplanted. I just realized it should be just a 1. Later, Knuckles. Thanks for coming. Now, let's take care of this supplantation again. Nice. This code, here it is. Hello, Manta Gaming 101. Let's see. I've got my gaps. I've got the chunks allocated. I've got this gap that I care about. I'm working on a text engine for my editor called 4coder. There's some information about 4coder in the description. If you want to look at some of the code, I'm not sure if I think I have the GitHub in the description, but the code I'm working on right now will be posted here later. today. It gets posted every day. I've been working on it for a couple weeks, as you can see on the day count. What I'm working on is called a multi-gap buffer, which is the third data structure that I've tried so far for text, for holding text in a text editor. And I'm trying to get editing working in the multi-gap buffer. If you want to see something live real quick, I'll take a quick moment because I'm a little bit I'm in need of a short 5-minute stopping point. Anyway, chunk init chunk out. Don't care about that. And init right there. Alright, here's the gap, or the multi-gap buffer, hopefully. Here it is working in 4coder, yes. I can do anything but edit it. I can scroll around, seek works, you know, arrow keys work, etc. I can do like find to do, and find bottom, and find return, and so on, right? So everything basically works. I just can't edit anything yet because I haven't got the editing function for the multi-gap buffer working yet, so that's what I'm working on right now. But for other data structures, like all that stuff works. Specifically, the golden array and the gap buffer are both finished. This is in C++. Okay, so replace range end. Yes. So here's where I was. Saying move something to the end of gaps. The amount that I want to move is this much, but what am I moving exactly? And the answer should not be gaps. It should be should actually be gap plus 1. This right here should be gaps plus, I want to move, oh man, gaps plus chunk count in this case. And the amount that I'm moving back is alloct minus chunk count. No, that's not true. It's alloct minus gap start minus 1. That's more like it. Chunk count decreases. No, so at this point this is different. I need to increase the chunk count. I need to say the chunk count goes up by, I've just taken some number of gaps and stuck them in there. Required empty buffers. So it goes up by that number, required empty buffers. Yeah, technically I don't want to take all of the alloc chunks, do I? So I have a little error in my figuring here. I need to back up. So what I actually have is I have a bunch of empty gaps that I can use. I have a bunch of null gaps over here that aren't even allocated yet that I have to not use and ignore. And I want a certain number of them inserted somewhere else. So it's like I want this many inserted right before this E here. Or, yeah, right before this E. So what I'm trying to do is take the E and put it here for now, since that's in null space and it doesn't really matter what it points to. And then shift everything down, but then I'm going to have 2 extra spaces that I don't need. And the trick is that all these empty gaps are just sort of lined up next to each other. But if there's too many of them, then it won't exactly work, will it? It's more like I want to put... It's like I'd have to do 2 supplantations in a row, because then I could shift everything down and then take the chunk that I don't want and stick it on the end and supplant down again. I don't like that at all, though. The other thing I could do, I suppose, is say that I take these. This would be the better thing to do, right? Is take these and save them over here, then shift these over to where they need to go, and then copy from here into there. So it'll just be 3 moves instead of 6. And it has the potential to be smaller. Well, it's definitely smaller than just combining both of them together into 2 big supplantations. So required empty buffers. If this is greater than or equal to required empty buffers, yes, yes, yes. Alright, so this is bogus, this is all bogus, ignore that. If this is greater than, if chunk max minus alloc is greater than or equal to required empty buffers, fill in this section later. Otherwise I want to grow the gaps by, I need at least this many okay. Now, I'm in here, that means I have enough space in the gaps array. So now what I need to do is mem copy from the beginning of the alloc chunk chunk from the beginning of the alloc chunk is plus chunk count. That's probably a bug I have here and there because I just realized that. So there's the beginning of the alloc count, or the alloc chunk. Here's the beginning of the null space. Alloc, or chunk. Alloc. Need to switch these around because I'm copying 2 here from there. How many am I copying? I'm copying things of this size. Required empty buffers of them. Okay. Then I'm mem moving from required empty buffers plus 1 from gap plus 1. How many is that? that I'm moving that chunk count minus some amount, and that amount would be I'm moving this many here, so here's my chunk count, here's start, so it's minus start minus 1, right? Okay, so that's how many I move forward to the right, and then I need to mem copy from wherever this is, this number again. So this is getting copied twice because I have to get it out of the way and then stick it in where I need it. And these things are pretty small, so these copies are pretty cheap, if I haven't mentioned it. It's the thing that comes after this that's actually expensive. This is just the part that's annoyingly complicated. Alright, so then the next thing it needs to do is put that into, yeah, +1. Alright, so if we've gotten that far, then we're now in a situation where, let me undo all this, I'll undo everything and start from scratch. So we're in a situation where we have all these chunks, and we wanted to do some edit that ranged like from here to here, but it did an insert that was super gigantic. It's bigger than my whole gap even. So now all this text here we've done some fiddling around. We have now determined that we need more empty gaps, so we have all the text up until like here, and then we have some new empty gaps, and then old text here, right? This text that goes on to there. And the goal is to get this new text, which is maybe like sort of square wave shape. The goal is to get it to, well, let's see, if it starts right there, it's kind of like maybe I took the rest of this and I expanded it. And so this little chunk here kind of exists over here maybe. And then the square wave goes in the middle. It's something like this. Something like this. But I have to think about the particulars. So these are gap buffers. So I have enough gaps to the right, but I have this edit that's like sitting right here. And I first have to figure out how I'm going to do this removal. To do that, I basically just need to figure out who to shift, which is going to be shift you to here, or if we're here, just delete this chunk and this chunk, or if we're here, shift you over here, right? And then delete everything in there. So that gets moving that around done. Then we have this chunk and this chunk after that stage. So we then have these two chunks and whatever thing we're trying to insert, right? Which I'll keep using square wave to represent that, which is too big to fit in between these two chunks. So then what I have is a new empty chunk right here. So then this all is going to move over here, leaving this open for having half the square wave here and half the square wave here, you know? So that's the steps basically. Is one, I gotta get this into, do the delete, this portion of the edit, and get it into two separate chunks, like this, and then look at my empty gaps, move this chunk to the end of the new set of empty gaps. So this one, for example, would end up right here, and then divide up the new text. Okay, that's manageable. I can handle that. So to do that, let me see. To do that, we'll just get going. If the start and end are variables that know where this edit has to happen. So if end is less, and this is kind of like this up here actually. So I'll take a look at this right here. Right, so this is saying where end and start, if needed, figure out how much we need to move, do the move, and update size 1 and size 2. So, and then do a mem copy and grow one of the sizes, size 2, size 1. Start. Yeah, so this does the actual, like, moving things around, but it doesn't do the delete, right? So now, after that has happened, we know that we're allowed to delete the chunk between start and end. So what I should do is say that, like, these are else, so that I can do the delete in an efficient way for each possible case, which is a little different than what I've done for the other ones, but those didn't have the same requirement as this, which was to separate the delete from the write. So if end was less than size 1, we moved that over there, and then we want to decrease size by what we moved, right, and then we just need to move size again. Did I ever shift start and end to be, I did that right here. I think I should probably do that outside. Right? So size -1 is move size, decreased by the move size, and then take size 1 again. This is a little bit sloppy, but who cares right now? Oh wait, and subtract. Okay, no. Okay, so what I need to do is subtract out also the size of the edit, right? Yeah. So that just deletes the text by shifting it out, basically, by moving the cursor out of where it is so it doesn't believe it's there. And then if I don't have to do the shift, then that's a nice position to be in. That just means that size 1 becomes start, and size 2 is a little trickier because it's like the fixed width buffer size minus end. Alright, take the full size, subtract out where the edit ends, and that gives me the right hand buffer. Makes sense. Anything else that I have to do to delete this? I don't think so. So then my next job will be to do that, but I'm going to take a quick break to go to the bathroom. Be right back. So there we go. Next up, something to do with this to do. I gotta do something with it. I gotta do. This does the delete. I have to do the putting the text in. Okay, so I'm actually the next thing I have to do is take the end of this chunk and move it to the end of all of the empty chunks. So that's kind of like that's a mem copy from the gaps. Second chunk, which I get to by the sum of these two sizes. From there to, I need the data of another gap. And the amount of that will be okay. Now I need to set dgap. Where is the position? There it is. Dgap is basically the end of the new array of the new sequence of empty buffers that I just set up. Where I spent these 3 moves here, these copies, setting it up, and where does that end? It ends at gap +1 plus required empty buffers. Yes, yes. Right. So there's your dgap. Wait, is that 1 too many? No, the required empty buffers doesn't count the original buffer, so yeah, I have to add 1 in to get to the base where it's 0. Somehow some of the math I did in here is fiddling back and forth between 1 index and 0 index now, which is a little weird. What can you do? It seems like I have to do it that way, though, so it's whatever. Right, so that moves everything all the way to the right. Now, finally, what I have to do is say, look, we need a for loop. And this for loop is going to start at where it is. It's going to end at gap greater than dgap. gap less than or equal to d gap. So it'll continue while gap is less than or equal to d gap. And it'll increase the gap each time. And at each stage, what I want to do is basically put in some of the text that we're trying to put in place, right? We got all this text we got in, and we need to get it out. So to look at that, it's sort of like, well, what it's actually like, actually, how do I scroll out a little bit? There we go. What it's actually like, oh, now that's bigger? That's a little weird. Alright, fine, it's bigger. Okay, so scrolling out doesn't help at all because then the thing gets bigger. So, anyway, what it's actually like is I have some buffers that are empty, and I have some text here, and I have some text here. Right, and then I have some new text that I would like to take up the space between these two guys, right? And what I need to do is say how many, let's see, how many bytes do I want to put into each chunk? Once I figure that out, I chunk them up. 1, 2, right, so it's like I have to do the end, and then increment and do the start, and increment, start, and increment, start. So the flow of the loop has to be somewhat wonky, actually, first of all. So it's like end, increment, that increment means plus plus gap, start, if gap is greater than or equal to d gap, then break. Okay, and then the question is just what do these two guys look like? Well, ending it is actually they're pretty similar. I mean, the figuring out the exact sizes will be a little bit fiddly. But what I can do is say like something like size per chunk, and that size per chunk needs to be the whole length of the text that I'm putting in place divided by the number of partial chunks that I have to store it. And if I have, for example, this many, let me draw these dividers a little bit taller so that they're nice and easy to see. Alright, so there's required buffers will be 3 times 2. Okay, so there's always going to be that much. That's not too bad. Required empty buffers times 2. That's going to round it down. I actually want it to round up, so it's like a div seal. There we go. You know, what I actually want to do is maybe a little different than that, because the first and end part could have a situation where this is less than what it needs to store. If they're both too small, then it'll run out of space when it tries to do this. So what I actually want to do is say, like, figure out how big this is going to be, figure out how big this is going to be, subtract those out, and then divide by this remaining amount. So it's like, which means that all of this wonkiness might just go away after all. Gap has to be less than dgap. Plus gap can go right there. And then what's up here is basically head size, middle size, tail size. And we'll figure these out like so. So the head size, well, let's figure out what middle size would ideally be. Right, so that would be the whole length divided by this was what I was computing before that I've now deleted, but it's fine, I'll type it in again, would be this much. Then I'll set these like so. Then what I have to do is say, look, if the head size is greater than gap, or if head size plus gap size 1 is greater than, I want to make sure I leave a little gap too. So it's hard to say how much gap I can afford to leave. What I could do is say, sum up all of the gap, the total amount of gap that I have, first, and then figure out how to do your distribution that way somehow. If you just say like, oh, give me 10 points here, give me 10 points there, I think you can provably say that since you got at least one whole gap buffer, the sum of this and this can't be more than one whole buffer, right? So that means this right here could go all the way to here, and it's tiny, but then this side over here will be big enough that it's big, which means if I just take like, oh, put a minimum of like a quarter of a kilobyte gap here, for example, and a minimum of a quarter of a kilobyte gap here, that's half a kilobyte total. That wouldn't necessarily fit, because this could be, well, if that's one whole thing, I think it would have gotten another one, right? That's half, and that's half, and that plus that's half, that plus that's half. If that and that are half of a chunk, it would have gotten each, if they're each half of a chunk, and those are the only two that exist, it would have gotten me 2 chunks. So there's always enough space for that. Okay, cool. So plus, what did I say, like quarter of a kilobyte is greater than fixed width buffer size, then head size equals all of this minus this, right? Same logic on tail size. So that makes sure head and tail are small enough to fit in place, but they try to be as big as everyone else is going to be in terms of the middle chunks. And then we can say recompute the middle size based on the amount of length left over and this up here should still be a div seal. I don't know what I was thinking there. So however much space is left over divided by required empty buffers minus 1 times 2. Right, and so then what that's saying is all the middle chunks, that's how many middle chunks we have. So that could potentially be 0, right? Okay, so we figure out middle size again. And then what we want to do is apply the head size first, which is the end of the first gap, right? So that means like gap size 2 equals the head size, and I want to mem copy into the gap data plus gap size 1 plus or plus buffer fixed with gap buffer size minus head size. Copy into there, copy out of the string plus position, like mem position with the amount being head size, mem position plus equals head size plus plus to the gap. Make sure your gap size has been fixed up. Minus alright, and then after that we can do head and tail of each of these. So that'll look something similar to this each time we do it, but with some differences. So size 1, we won't figure out gap until the very end. We won't increment gap until the very end. Mem copy into data plus nothing from string mem position, the middle size, and then increase by the middle size. Go to the middle size, and then gap size 2, with the logic here being start from the end and then subtract back whatever you need to subtract back, and copy that in, set the middle size, increase, set the gap size, increase the gap iterator, and then at the very end we'll set kind of like we do up here, but with tail size now. It's actually not so much like this, it's more like this. Oops. Tail, tail, tail. And then I need to do this work again. And then I should assert that the mem position is exactly equal to the len of the string we were trying to put in. Cool. Oh, there's like a million problems with it. For starters, we're not keeping track of we aren't keeping track of the rounding situation here. So there's a good chance that very often it'll overflow the buffer that it's reading from and write out some bogus, and it'll paste in more than it should. So what I have to do is keep like a opposite of mem position situation, or I just use mem position actually will be better. Every time I go to do something, I say here's the size I'd like to use. If head size is greater than len minus mem position, head size equals len minus mem position, right? That'll just happen on all of these things. So this will happen down here on the tail. And up here it'll happen with both of these, right? Tail size is, if middle size is greater than len minus mem position, middle size equals len minus mem position, right? So that way you get the right middle size for each of those. If you ever need to shrink it down, it'll just shrink, and then everything else comes out to 0 after that. Okay, so that's a good fix. Well, obviously I have to introduce a bunch of variables that I'm not actually declaring. And head size, middle size, tail size, mem position. There we go. Whew. So this figures out how to distribute out this new text amongst the buffers. Now, the other thing that I've completely ignored so far is that none of this is thinking about the start position, which every buffer needs to be thinking about. So, first of all, up near the top, let me read through again. We know the total shift amount out. So everyone after the end gap end here, everyone after that needs to just be told that their gap end has increased or decreased by this amount, and that's like it. That's all that has to happen. So, and you know it, even end himself will have that, right? No. No, the end has a different shift amount, so I think that one should be a part of the process of recomputed start positions, which will happen at the very end. But at the very beginning, what we can do is say, before we do all the real stuff, we only want to do this once though. This is one of those things that should only happen once. So this will actually be edit stage 1. That's edit stage 2 there. And look, if we're on edit stage 1, that means this is the first time we've called this thing. Then we can go ahead and do our shifts of the start positions of the chunks after gap end. So gap equals gaps plus gap end plus 1. Right, that's like a beginning of a for loop, and we want to check the gap remains less than gaps plus the total number of currently interesting gaps that are valid loop and across that. With each of those, gap start position should increase by the shift amount out. So that's pretty cool. That just works, I think. And then we need to say that the edit stage increases to 1, so that if we repeat this, this part never happens again. And I can't include that in here because a lot of this stuff happens twice. Like I could include it right here maybe, but that would involve changing gap more than once in here, just sort of unnecessarily. This seems like the nice straightforward thing to me. Alright, and then the other trick is once we are like going through and do all this memory crap, and we finally get to finish the edit. So this right here sets result to 0. And this right here kind of is the same, right? So these two guys here both have successfully completed editing, but in a different way. So they both want to set edit stage to 0 for one thing. But the other thing they have to do is update all of the start positions that they might have affected. Now the gap itself shouldn't have been affected, right? But everyone else after that and up to and including gap end should be affected. So this concept down here of dgap is totally unrelated. Basically if we're in here, okay, so basically if we're in here, the only thing that has to change is possibly the next one, if the next one is the gap end, right? So if the next one to the right was also affected in a different way than an average, apply to, well, move gap forward 1, and then its start position is plus equal to local shift amount. I think that's right. And then down here, I think with this one, the easiest way to do it is to keep track of start positions in this loop, because the start position of each of these is basically the start position of the original plus the size of each previous gap buffer, which we just sort of have computed here nicely for us. So yeah, I want to have like equals gap start position, and then after that, well, less than dgap, we do that, we do start position plus size 1 plus size 2, and then with each of these we go to the next gap, we take its start position, we set that equal to the local start position, and then when we're done, I want to take this and add in these guys. Maybe if I do this, it'll do some clever register stuff for me, so I'll do that. Let's see. So that's updating all of those, but then I still haven't set the start position of this last one down here. But that's okay because now I have, right? Brilliant. So, does that work out at all? I mean, there should be about 1 to 2 million bugs in here, given the amount of code that I've had to write to get this started. But now, I think it's all there. So I'm gonna just do something crazy and run it. See what happens. Okay. So I haven't done any edits yet, so everything still works. Let me see if I can insert the character A. Can't insert the character A. But that would be expected because I haven't gone and lifted the scalpel in the important places. So let's see about abstract, for example. Do you anywhere in here need me to lift anything? No. How about somewhere else in the program? In here, for example. File save. Buffer convert out. I think that should be possible now. Yes, it is. File close, do not have that yet. File post undo, do not have that yet. 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 Do single edit. Yes. Yes, this we do have. Oh. Very true. Mem position equals 0. Saying result is potentially uninitialized now. Well, it should be initialized to 0 at the head end, I should think. Is it one of these go-tos that's causing potentially... Oh, it's if it goes through this path. It was... Okay, interesting. So this path... Result equals 0. Cool. Can I insert the character A? Aha. Something's busted. Command right character, view replace range, do single edit. It came in here and it busted. So now we can really get down to the nuts and bolts of this operation and see what's actually happening. Insert the A. It says here's the string. I'd like to start and end the insertion there and there. The string length is 1. Don't know anything about a request yet. So it comes in here. It says what's the buffer size? It's pretty big. It works. That's fine. It's an increase of 1. That's correct. Those should both be the same, and they're both 0. 2 makes sense. Edit stage 0. Yes. Takes everyone after this position and increases their start positions. It's about 25 of those. Shouldn't cause a problem. Gaps plus gap start. Right? So we get the first gap again. It's not less than that, so we on to edit stage 2. For this one, we look at, are we greater than there? We're not. Okay, so now the shift amount here should be 1. Cool. Start minus equals gap start position. Right, so it's localizing start and end to the correct spots. Makes sense. Shift amount plus size 1 plus size 2. Yep. Data. End is less than size. It is. Does the mem move that it needs to do. decreases size 1, increases size 2. Data plus start. String. Copies that in. Size 2 equals size. No. That's absurd. Can't use size there. That's got to be handled differently after all. Yeah, everything down here handles that in a smart way, but 466 bug. Alright, so let me figure out how a better way to update size 1 and size 2 in this case. Basically, size 2 says look at the end of this and do buffer fixed width buffer size minus end. So making sense, start and end they're in absolute positions, not in memory relative position, so I need to add in size 1, but which size 1? Before the edit, after the edit? I'm not sure. Before the edit, right? I need to add in the size of the gap too. Gap plus. Actually, I just need to add in the size of the gap. Yeah? But only. Oh, we always assume, so after the end, basically it's... this is all kind of confusing, I don't like it. So we're going to find a different way. Size 2, how do I compute you? After the edit is done, actually, I think this was correct, and I'll leave it at that. That's the best I can think of. Then I update size 1 by... That seems right. Gap size decreases if the shift amount is positive. That seems good. Maybe this is better. Okay. So it's coming. Oh! Alright, let's try that again. Meant to step into that. Oops, don't want this. Don't want this. That all makes sense and works fine. We've already checked it. There we go. Okay. Cool. We're moving the text over so we can do the insert. You do the mem copy to put in the A. You set size 2, which hasn't changed at all. You set size 1, which is now 160. That's good. This goes down by 1. That's good. But size 1 plus size 2. Oh, it should not equal size plus shift amount. What are you talking about? Wait. Size 1 plus size 2. That's the whole size, though. So, what I actually want if I'm going to assert that is I have to know the original size somehow. And the original size is just those. I'm going to say I'm going to take that assert out because it's too difficult. Or what I could do is say we have a debug variable. That seems fine. Okay, so it comes down to here. Skip through those. Nothing needs to happen there. And it does the move on the memory, does all the updates. Those pass. We're done with our edit. We set back to edit stage 0. Gap start is not even less than gap end, so we don't do that. Hey, there's an A there now. Let me see if I can do some of the basics without trouble. A. Ha ha ha, this is so cool. Alright, so single little small edits are working, but whoop-de-doo, that was the easy part, right? That doesn't even begin to test the complexity here. So let's do a real test. First of all, let me go down to the bottom and edit in another location just to make sure that it's working if I'm like in a different chunk. Find bottom. A. Oh. Not working at all. It's actually totally frozen. What are you trying to do that is so difficult for you? You went in to do the single edit. You passed the part where you did the replace range, but you screwed up after that. 2932. 2932. Replace count 0. New line count 0. Line shift 0. Remeasure starts. And then you came down here to remeasure the starts. You started trying to stringify and you got stuck into an infinite loop. Let me see what's going on there. So you're good. Okay. So you look at the gap you're on. You say chunk guy is 172. End is chunk. How did we get past that, I wonder? But anyway. Gap sign. This is all bogus. Bogus. Bogarino. Bogicide. So you think your position is still weird. You do that. It's bogus. You come down here and you go look. While char I is less than end, and it's like totally bogus. And then you just do the same thing again and again and again. So how did you get to the point where you thought your chunk I was 172? I wonder. Well, I wonder if this is just a matter of me saying if chunk I equals chunk end, get out. It could be greater than or equal to, but I don't think that should be possible for it to become greater, so I wanted to read the code and see if anything in there makes sense. Why this would be happening. Say I'm here. Where do I compute chunk end? Find chunk end minus 1, whereas chunk start is start. And we know that start is less than end. So I'd really like to see that happen after I do the edit. So okay, so I'm going from 159 to 160. Oh wait, this is gonna work. This isn't the problem position. Do that, fine. Whatever. Take me to the bottom. Well, that's weird. I have to deal with that at some point, I guess. But let me insert my A now and watch what happens. Oh. We went down an unusual path. Okay. Alloc minus chunk count is greater than or equal to. Right, so the amount we have is greater than required empty buffers. Why would shift amount be this big? That's not even shift amount, that's the size of the buffer. So what the fuck is that? Len is 1, end and start. How is end 0? You subtracted the start positions, which are apparently both 0. Which doesn't even make any fucking sense either. Let's back up one level. Start, end are both big here, right? So, wait a minute. I cap end and then I decrease it again. I should cap end after I decrease it, right? That would make some sense. That would make some sense as opposed to whatever I'm doing here. Right now, it just doesn't make any sense. There we go. See if that's any better. Yep, you're gonna start stopping every time you stringify the buffer. Makes sense. Okay. I place an A. It comes through and says, alright, you're placing an A right here. Let's see what it's gonna take to make that happen, shall we? Goes to the next. What happens while it's going to next? It should look and say, okay, these two guys are the same, and the position we're at plus 1, 8191. Wait a minute. Results.end. Where do I set that? Okay. Let me walk through that again, because I see what might be causing this now. But I prefer to see it happen. To the bottom. Insert the thing, set that up, step in here, start, and end. And then it goes, okay, here's your chunks. Here's the gap you care about. Take that and subtract out that. 592. 592 is less than the size, so you get a result. End of 590. End 592 is less than size and 8191. I think this needs to be less than or equal to. Okay, so start and end. After that, end is 592. Okay, that's what I would have expected. Now the gap ranges from 25, chunk end. It happens to be the same one, it won't always be, so that's fine. 591 of 592, that makes sense. Temporary end equals 592. If that's too big, we decrease it. It happens to actually be equal, so nothing happens. Temp end. So we get a size of 1 and a data of a. Very good. Very good. Then we do the loop. We see what we're dealing with. And we actually get out of it. Okay. Loop. Aha. Uh-oh. Always something. Alright. Let me take a look. I'm gonna take a look at this one. I'll take a look at this one more bug, and then I'll take a break for a little bit from streaming and keep working on this off the line. But I think that it's been a pretty good stream, so I'll finish it up with this one more bug. Size 1 minus equals local end. That's crazy looking, isn't it? Why would that be that big? Why would local end be so big if it's going to be subtracted if size is greater than or equal to local end? Otherwise, I think these might even be backwards. What is this code doing? So we're in edit stage 1. We come down here and say, okay, what is local end? And local end is the end of the position minus my start position, which is 0. Gap start is 25. Oh, but I've stepped one past that because I started at the very last one. So what I need is like a clause where it's like, look, what if gap start plus 1 is, yeah, okay, so 414. And gap start plus 1 is less than the buffer chunk count. So if we're not at least gonna have to have some movement there, then don't even look at it. Like, don't bother, right? Only go and move stuff around if there's something to move. A backspace A. Alright, well, I've fixed the one that I said I was going to fix. This is somewhere else. So I'm going to keep working on this on my own. It's obviously going to take some time, some doing to get all of the kinks worked out and set up a test. I'll probably have to set up a unit test or something to test it against the golden array and the gap buffer so that I can verify correctness on a bunch of tricky stuff. But thanks for coming out to the stream. I'll post it on YouTube